All right, here we go, one more try, right? Place 2 points randomly in the coordinate plane. Use them to create a right triangle where the segment between them is the hypotenuse and the legs are horizontal and vertical. So I need to get a horizontal line. So what I would do is I would construct a parallel. It's going to be parallel. If I want horizontal, it's going to be parallel to the x-axis and go through A, point A. And then I want to make one that's parallel to the y-axis that goes through point B. And notice that now I've got them, since they're definitely horizontal and vertical, I've got a right angle in here. And if I find the intersection point, I can make that into a triangle, a right triangle. Hello? Okay. Wow. Jose, you're done. You take your stuff with you, all your stuff, because you won't be coming back. Thanks. Okay. So now, hey, guys, I'm still recording right now, so I need you guys to make sure you keep your voices down. So we've got these two lines, they intersect here at C, right? So I used the intersect tool to find the intersection point, and I clicked on the two lines, those horizontal and vertical lines for where they intersected. There's somebody out there that'll let you in, Jose, and if not, let me know. Now I'm going to get my polygon tool and connect A, B, and C into a triangle. That's a right triangle. You had to use the construction menu and go through parallel. Select parallel lines, make them parallel to the axis, going through those points. Okay? So if you can't keep up right now, that's fine. I'm going to post this recording and you'll be able to do it then. But I'm going to keep moving so the recording isn't 45 minutes long. Okay? So then it says, can this always be done? So let me just try this real quick. Watch. I'm going to hide that line and just say, if I have 2 points randomly in the coordinate plane, can I always make a right triangle out of them with horizontal and vertical legs? And the answer to that is no, not always, because look, if they're completely horizontal, well, then it wouldn't be a triangle, right? If it was completely horizontal, how would I measure that length? I would just use the x-axis to measure the length. And if it was completely vertical, I wouldn't make a right triangle, but I could just measure that using the y-axis to get the length, right? So it isn't always going to be a right triangle, but the few times when they're not is when they are aligned horizontally or vertically, in which case we can measure length using the x and the y axis to help us measure, right? But any other points, you can make a right triangle. And what that means, this distance here, right? This distance from A to B can be measured using the legs, right? This AC, this leg, and this leg here, CB, this horizontal and vertical legs. If I can find those lengths, which I can, using the y-axis, and using the x-axis, I can find those legs too, right? And then I have Pythagorean theorem that says leg squared plus leg squared equals the hypotenuse squared. The leg squared plus the leg squared equals the hypotenuse squared. Okay, so in level 1, I would need to be able to explain, show that I've been able to create that, right, first, because I've done this part here where I've placed it. And then I would explain that it can't always be done if they're vertical or horizontal, but in every other case they can be done. Yes, sir? Yeah, no, you can watch and rewind the video to watch it, because I'm recording right now. Okay, I need you guys to make sure you keep it down, okay? Using the triangle created above, explain how you can find the measure of each of the legs. Well, how could I find the length of a leg, this leg here, from A to C? It turns out that they have an x value here and a y and an x value here. So if you look, point A has an x value of 3.44, and point C has an x value of 12.24. So I'm looking at how did it get from 3.44 to 12.24? I can just subtract. And that would be what, 8.8, I think, or something like that. So in other words, this x minus this x will give me that length. This y minus this y will give me this length, right? Then it says, what if I didn't have the points themselves, just the coordinates? If I didn't see this part of it, if all I could see was just this coordinates here, I could still subtract the x values and subtract the y values to find the difference, right? If I could subtract the x and y values, I wouldn't actually have to even see. This would be x minus x in length. This would be y minus y in length. Okay? And then can this always be done? Yes, it can always be done, although sometimes a horizontal or vertical length, again, if you were to make it vertical, then x minus x would be 0. And if you made it horizontal, then y minus y would be 0. So you could always subtract, you might just get a value of 0. That's level 2. And level 3, you would use Pythagorean theorem, right? And so Pythagorean theorem, I'll put some text in here. You've got to make sure you understand that. Pythagorean theorem, which says, the leg squared, right? Oops. Oh boy, I think they're going to need me to put some spaces. Oh, they're wanting it to be, I don't want that to be that. Leg squared plus the leg squared is equal to the hypotenuse squared, which means if I had x minus x, that's my horizontal leg, and I squared it, plus the y minus y, that's my vertical leg, and I squared it, be equal to the length or the distance, I'll call that distance, of the hypotenuse, right, between those 2 points squared. Okay? All right, and that would be the equation that would work for any 2 points. If I have 2 points, all right, so if I have a point, let's say point A, and its coordinates were x of A, comma, x of B, and I had point B, x of A, y of A, and then I had point B, and its coordinates were x of B and y of B, then I would always be able to say, well, if I take those 2 coordinates, xb minus xa, that would be my vertical or my horizontal leg, and square it, plus y of minus y of a, and I squared that, it would always equal the distance between A and B squared, right? So we say okay. So there's some notes there to kind of walk you through how you could just take those coordinates and plug it in. That's level 3. And level 4, this is given the definition of a circle is a set of all points the same distance from a center point. Write the equation from the points x, y that are 3 units from the center. So now I'm just going to try to get this figured out, let's pretend that the circle is 3 units from here, right? The circle is 3 units from here. Okay? And And actually, you know what I'll do real quick? Let me just get a new screen in here. So if I were just, let's just start with the center 2, 3. So I'm going to put a point here. Let's put it down here. I'm going to type in 2, 3. Okay. And then from there, I want a line. I'm going to make a line with a given length. And the length is 3 units. Okay. Okay. So now that means B can be anywhere as long as it's 3 units away. Now, let me see if I can turn the animation on and the trace on. So if you notice what happens in that situation, I've got a fixed distance, 3, and I'm finding all of the points that are 3 units from this center point. What shape do I get? I get a circle. I get a circle, right? And I can use Pythagorean theorem to define this circle, and here's how. Again, watch again. I'm going to turn that animation off. So having done what I did before with parallel lines, I'm going to do it one more time real quick. Parallel to the x, parallel to the y. Force this into a right triangle. I'm going to find the intersection of those 2 lines. There's C. And I'm going to turn that into a right triangle. And I've got a horizontal leg and a vertical leg, right? So even if I hide those lines, H and C, no, C I want, G, put those lines out of the way. When I animate this again, you can see that there are tons of right triangles that define that circle. Tons of right triangles made up of horizontal and vertical lines defining that radius. So let me put some notes in here. So the radius, let me start with this. We had the center defined as 2, 3. The radius was defined as 3 units, right? So what do I know? I know that the points on the circle, which I might call X, Y, right, have to be 3 units away from the center, 2, 3, the center, right? So I know that's true. So now I have to figure out how could I write an equation that would show that these points are that distance away from the center. So this is really the important part here for your work that you have to do. You would say, I would take the x from the point on the circle minus 2, which is the center of the circle, square it, then add it to y minus 3 to get my vertical difference and square that. And know that has to be equal to the radius, 3 squared. So let's go through this again, and I'm going to pause this so you can see exactly what I mean by this right here. X minus 2 is this length right here from A to C. This is 2, and this is some point X right here, right? So this length would be X minus 2, and this vertical leg would be Y, whatever this point Y is, minus 3, because this center is at 3 on the y-axis, right? Center's at 2, 3. So this distance is x minus 2, and this distance is y minus 3. Okay? So here we have one leg squared plus another leg squared equals the hypotenuse 3 squared. That is just a regular old formula you can use for any circle. Now it says, instead of using 2, 3, and a radius of 3, what would the equation be if the radius was r and the center had coordinates h, k? Well, it would look like this, right? It'd have the center is at h, k. The points on circle are going to be at x, y, some generic points x, y, and the radius of the circle will be r. So what do I know about that? Well, I can get the horizontal leg, x minus h, and square it, plus the vertical leg, y minus k, and square it. And that will have to be equal to the radius squared. Okay? There's my formula for a circle. Now, if you go into your calculators and you go, what is the equation of a circle? You can go into graph mode and go, graph entry edit, look at equation templates, and look for the shape of a circle. You'll see that they have center mode, and that means if you know the center and you know the radius, you can create any circle. Okay? Let me give you an example now. Let's pretend my center is at 4, 5, and my radius is 2. Actually, let me get my screen moved over just a little bit, and I'm going to go, let my center be at -3, +4, and a radius of 2. So I'm going to say my center is at -3, +4, and I want a radius of 2. Well, then I would say x minus -3 squared plus y minus -2 squared has to be equal to 2 squared. Actually, it was a positive. I don't know why I said -2. It was y minus 4, +4. All right? So there's my formula, right? X minus a -3, because the x value here is at -3. So there's my horizontal leg. And here's my vertical leg is going to always be whatever point y minus 4, right, to find the length of that vertical leg. If I square the horizontal leg, square the vertical leg, and square the radius of 2, I get 4, and I get this equation. A circle with radius of 2 and center at -3, +4. So this one is just saying, hey, at this level, since now we kind of understand, and you may not yet, because obviously you're just kind of looking at this, but if I have a center at -2, 0 and a radius of 3, and I need to get the equation, I know I'm going to use this kind of an equation in here. I'm going to use this formula in here, but they're telling me the center is -2. That's my h value. The y value of the center is 0, so this is h, and this is k, and this is r. So I can go back to this formula. Wherever I see h and k and r, I'm going to plug in -2, 0, and 3. So let's try it. Here I go. I'm going to say x minus let me go in parentheses here, x minus -2 squared plus y, parentheses, y minus 0 squared equals 4 squared. Right? It was just, oh no, 3, sorry. The radius was not 4 squared. The radius was 3 squared. So that see how I'm changing this in here? 3 squared. So now I have a circle's equation. I put it in as x minus negative, which changes to x plus 2 squared, plus y, should have been y minus 0, right? Because the y value was 0, right? So it just became y squared. Y minus 0 squared is y squared equals the radius squared, 3 squared, and it became 9. And I will put in the center of the circle so you can see, there it is. The center of the circle is right here. My radius is exactly 3 units from -2 to 1, from -2 to -5. That equation did exactly what I needed it to do. So you need to be able to graph that. And what is the equation? Explain how you know. The last piece on here, I think I'm going to make a separate video for. It says complete the square to find the circle center and radius. And I think I'm definitely going to make a separate video for that one. So I'll stop here.